Yes, I think I'm recording. We are looking at our review for college algebra for the semester one final, um, and here we're given two functions and asked to find the domain of this new function f plus g. Well, what's amazing is I don't even have to find the equation for this f plus g. I can find the domain for this new function f plus g by finding the domain of f and intersecting it with the domain of g. So hopefully we're getting better and better at doing this. Um, the domain given an equation is a set of all real numbers excluding any values that cause division by zero, also excluding any values that cause us to take the square root of a negative number. Don't have any square roots, so I can see right away that f does not like working with the number 4 because 4 minus 4 is 0 and 3 divided by 0 is undefined. I have to throw 4 out of the domain of f. And for g, even though g is not typed there, for g, it doesn't like the number 2 because 2 minus 2 is 0. Both of these have to be true at the same time. This intersection, we think of it as the word and. So we've got x not equal to 4 and x not equal to 2. If I draw a quick number line, 2 is less than 4. Those are the only two values that cause division by 0. I don't have to throw out any other real number. So I want to describe this infinite set of numbers. It's almost the entire number line. It just excludes two values. So the domain of f plus g in interval notation is from negative infinity to positive 2, excluding positive 2 to 4, excluding 4, and 4 to positive infinity. In set builder notation, it's a set of all x, such that x is an element of the set of real numbers, and x is strictly less than 2 in this interval, or in this middle interval, 2 is less than x, which is less than 4, or in that third interval, x is bigger than 4. You'll never have the infinity symbols in your set builder notation. We only have inequalities, and we never use infinity symbols when we write an inequality. Alright, so let's move on to the next one. The domain of f minus g is the same answer. The domain of f minus g, the domain of f plus g, the domain of f minus g, the domain of f times g are all the same. And even if you change the order of the subtraction, it's the same. So all I have to do is steal my answer from part A, that all real numbers except positive 2 and positive 4, and that is my answer for part B. So let's change the addition symbol down here to subtraction so that everybody knows that we're claiming it's the same answer. So there we go. You just intersect the domain of f with the domain of g. Now division may or may not be the same answer. So the domain for f divided by g, again, I use the domain of f intersected with the domain of g. But I also have to be concerned that this g, the output of g, is in a denominator and it can't be 0. Alright, so I can see the domain of f is excluding the number 4. We've already seen that. The domain of g is excluding the number positive 2. And when would g be 0? When would this fraction reduce to 0? A fraction reduces to 0 when the numerator equals 0. So if x equals 0, this fraction will be 0. I want to avoid that from happening. I need to throw 0 out of the domain. So the domain of f divided by g is all real numbers excluding 0, excluding positive 2, and excluding positive 4. All the other numbers are fine. None of the other numbers will result in division by 0. We didn't have any radicals to even worry about with either one of these functions or with the division of these functions. So we want to describe this infinite set of numbers. we're familiar with two ways to describe it: interval notation and set builder notation, and the domain of f divided by g. The left arrow is shaded, that's negative infinity, all the way up to 0. There's a break at 0 from 0 to 2, excluding 2, all the way to 4, excluding 4, and to positive infinity. If I were to write that using set builder notation, I have the set of all x such that x belongs to the set of real numbers, and this left interval, x is strictly less than 0, or in this interval there to the right, x is between 0 and 2, or to the right of it, x is between 2 and 4, 2 less than x less than 4, or x is bigger than 4. You'll never have infinity symbols in inequalities and never in set builder notation. In part D, we want to find the domain of the reciprocal of, so we've got the domain of g over f is the domain of f intersected with the domain of g, but this time we have a new denominator. This time we want the output of f, keep it from being 0. So when we look at f, it's a fraction 3 over x minus 4. Hey, there's no variable in the numerator. This fraction will never reduce to 0. I don't have any other restriction to add, so this is just the domain of f intersected with the domain of g. The domain of f excluded 4. The domain of g excluded 2. So my domain of g divided by f is from negative infinity to 2, from 2 to 4, and from 4 to positive infinity. All right, hope that helps.